Hello, dear children. We were discussing questions from dual nature of matter and radiation, and today we have one more question, that is an NCERT question. As you know, NCERT questions are very important in the exam point of view. So let's go through the question. The question is: the photoelectric cutoff voltage in a certain photoelectric experiment is 1.5 volt. What is the maximum kinetic energy of photoelectrons emitted? Okay, so let's go through the theory part of this question. An experiment performed by Holworth and Leonard, and the experiment was okay. So we have two electrodes. First one is C and another one is A. So C is applied with negative potential, and A we are applying positive potential in the first part of the experiment. So when you apply negative potential at C, electrons will be emitted, and these electrons will be accelerated towards the plate A, since A is having positive potential. Okay, so in the second part of the experiment, we are applying negative potential at A, so that the electrons coming from C will be repelled by this negative potential, and as we increase the negative potential at A, more and more electrons will be repelled. And as we know, in a beam of electrons, all the electrons will not be having the same value of kinetic energy. Kinetic energy of electrons will be different. When we apply a certain potential, negative potential at A, so that the electrons in this beam of electrons, even the electron with maximum kinetic energy will be repelled by the negative potential applied at A, and that particular value of negative potential applied to A, so that the electron having even the maximum kinetic energy will be repelled, then that negative potential is termed as stopping potential or retarding potential, and it is indicated as V0. Okay, so in order to repel the electron, work must be done, and what is the expression for work done? It is Q times V. Here instead of V, we are representing the potential as V0, and this V0 is known as stopping potential. Okay, so this stopping potential is negative retarding potential, negative value of potential or retarding potential that should be applied in order to stop even the electron having the maximum kinetic energy. So this work done will be equal to the maximum kinetic energy of the electron. Okay, the kinetic energy of electron will be equal to the work done to stop the electron. Work done is equal to the kinetic energy of electron, so that the electrons can be stopped. Okay, so we can substitute for W. So QV naught, so Ek value appears to be Q into V naught, and as we know, in the case of electron, we can replace Q by E, which is the charge of an electron, magnitude of charge of an electron, and equal into V naught. And as we know, the magnitude of an electron charge is 1.6 into 10 to the power minus 19 coulomb, and V naught as it is given as 1.5 volt. So listen to cutoff voltage means the stopping potential voltage the same, so 1.5 volt, so it will give you 2.4 into 10 to the power minus 19 joule. As we know, these are given in SI units, so we'll be getting the kinetic energy also in SI unit, which is joule. So that is the answer. We will be discussing the theory part once more, so let's take a look at the theory part. Photoelectric current is zero when the stopping potential is sufficient to repel even the most energetic photoelectrons with the maximum kinetic energy, so that the kinetic energy maximum value, it will be equal to EV naught. Okay, so the negative potential applied at the plate A should be enough, so that a work done which is equal to EV naught should be sufficient to stop even the electron having the maximum kinetic energy. That is why we are writing it as K max equal to EV naught. That is, the maximum kinetic energy of electron should be equal to the work done to stop the same electrons. Okay, so work done is equal to maximum kinetic energy. That is the clue for or the theory part of this question. Okay, thank you.